Ladies, gentlemen, and troglodytes, welcome back. We are going to look at this drill master, call these quarter sheet sanders, and find out if it's any good. Spoiler alert, it's fucking not. So, man, here's the thing with these things. So, we're looking at the sander. I want to show you the sander because I just bought a new sander, and this is going to show you why I bought a new sander. So this is Harbor Freight, or Drill Master, if you are gullible. I think it's like a fake brand. I think they actually incorporate them, like they're companies, but they're just all owned by them. And the reason they do it seems to be so that for warranty claims, like they can print on the box, like, oh, it's, 3-year warranty. Not that they have that at the Harbor Freight, but whatever warranty. And then if you make a warranty claim, they say, oh, we didn't make that. Fucking the assholes at Drill Master made that. So if you want to do a warranty claim, you got to call Drill Master. They're going to solve your problem. So it's like the whole runaround thing. So you have to call Drill Master. You get connected to the same service person as every other Harbor Freight brand. So Drill Master, Chicago Electric. I don't remember what the other ones are called, but they're pretty much all the same thing. I'm sure it's the same call center. And you call them up, and then it's like, oh, you got to mail it to us, and then yada yada. Do you have your receipt? But it's so you can't return it in the store, right? If it just said Harbor Freight on it, they'll have to handle your returns. And they don't want to handle your returns because they want to make it enough of a pain in the ass that it's not worth your time. So you just don't do it. So that's sort of seems to be the game with warranties, is you give a warranty and then you do everything you can to make it a pain in the ass to actually make a warranty claim. And then, some percentage of people, as many as they can get, who actually want to do a warranty claim are just eventually like, you know what, fuck it, I'll buy another sander. So, they make an extra couple bucks off you, and they still get to put the warranty on the box. So, this thing, quarter sheet sander, orbital, kind of they're using that term loosely. It gyrates a little bit, but it's basically just like a forwards and backwards sander. It's not a random orbit sander, which is really what you want for more than one reason. So these things are standard. They're all over the place. You can get these quarter sheet sanders, and it's pretty much the exact same design, at least on the outside. It was the same idea from Milwaukee or Ryobi or whatever color you fancy. If you play for the blue team, you get a blue one, whatever you want to do. They fucking suck. They all suck. If you buy the most expensive one of these in the world, it's still gonna suck. And I'll tell you why. Because I'm sure the motor in here is fine. I haven't had any problems with this in terms of it running. It runs fine. The brushes are still good. Everything's fine. It's just a bad design. The thing just barely works. And the problem with it is going down at the bottom here. This retention system. So these are just loose sheets of sandpaper, these quarter sheets that you buy and you stick on here. And it's held on with these little clippy things. So you pull these springs up right there. So you see this spring bar comes across here and it clamps it down. Clamps it down all across here. There's another one. Clamps it down across here. So you take it here. I'll actually leave it on for a sec because I want to show you this. So the problem with these, first problem, is that you can only get it so tight. However much time you spend trying to fit it in there, the sheets of sandpaper seem to always be slightly longer than these things are, and so you see the slack, right? Like hot dog down a hallway in there. So the problem is, like, half the throw of this thing moving back and forth just moves the sandpaper. Like, if this is the actual sander and this is the sandpaper, it's like you go half the throw and then you hit the edge of the sandpaper and then you pull it a little bit. Then you go half the throw back, hit the other edge, pull that edge back a little bit. So they take forever to sand anything. Because even if you get this thing super tight, I'm sure someone will tell me, like, oh, you put it on wrong, it's not on here enough, it's not tight enough. As soon as you start sanding, it's going to loosen up. So you're going to be in this position whether you start here or not, and it takes forever because for every stroke it does, you're getting like a half at best of a stroke, right? Because it goes like this. Sandpaper just goes back and forth. And it fucks your sandpaper. So this is a sheet that came off of this, and obviously it's like barely used. Sanded like half a pass, right? This is all new sandpaper, ripped instantly. And the reason is, if it goes on there a little bit squiff, if it's a little to the side or something, corner to corner, then when this thing, it goes loose in the middle, as you pass over it, then it hits the edge of the paper, loose hits the edge of the paper, so you're power fisting the sandpaper. Every time you get to the side, if it's a little bit torqued at all, you get some sort of shear in here and it tears your sandpaper. So you go through tons of sheets of sandpaper like this. It wasn't as bad when I first got it, but I think, you run it for a little bit and these things get loose. They lose their springiness or whatever. You're certainly not fucking using spring steel, right? So these things loosen up. There's another problem. They're not affixed in any way. So it goes around the side here, it comes around the back, and it sticks into this plastic tab on the inside. There's a little hole, a little detent or whatever you'd call it. So it comes around and it sticks in there. Show you the stupid thing. Come on. Fucking. So now you're getting the experience of using one of these. Every time you change the sandpaper, or more realistically, every time your sandpaper comes off because it sucks, right? You're like, oh, I'm gonna take this off. It was right in there. That's great. And then it just fucks off. Oh, boom. And then you drop it. It's on the fucking floor. It's all over the place. It's terrible. So these things suck. This is the design flaw, right? Like, this is just not a viable design. It doesn't really work. It works okay, and it did work better at first than it does now. I think because these bars loosened or stretched or whatever. But it can't hold the sandpaper to itself. And even if these work perfectly, even if they clamp down super tight, you're still gonna have this problem where you're moving the thing and boom, and then you move the sandpaper, and then boom, and then you move the sandpaper. And you're doing like a quarter of the sanding you're supposed to be. And it's gonna shoot your sandpaper, power fist in the sides of it. It's fucking stupid. Alright. Other problem with this thing. This is a Harbor Freight special. They're probably not all like this. I don't know if you can see this. But this thing has a wicked bend to the side, man. Hopefully she doesn't mind, but right, don't want to test it. So it's like not even close to flat. It probably isn't focused at all, but fuck, man. So when you sand with this thing, this one is like bent over like this. So when you sand, you just sand here and here, and it's like it's not even. That makes it even slower because you have half the area at best. Oh man, these things suck. So if you're gonna get one of these, don't. That would be my advice to you. They're cheap, right? That's why I bought this, right? Because I'm a poor bastard. So I want a sander, and I want the cheapest sander I can buy, which, right, is the Harbor Freight business model. So I go in there. Even Harbor Freight sells nicer sanders than this, right? So we should point that out. Even Harbor Freight has like multiple lines, right? You can get the nicer fake brand instead of the cheapest fake brand. And, it's probably less shitty. But my point here is that even if this isn't Harbor Freight, like I was in the store the other day, and like I said, they got these in every color, every team. Dude, they're all gonna suck, man. I looked at them and they're exactly the same. These like the springs down the side. The only improvement that you get on buying one of these from like Milwaukee or DeWalt is that these tabs that the edge of the thing retains into, they actually hold it in. So where this one is just like sticks in the edge, and when you wiggle it, it just pops right out and falls out. There's more plastic around here, and it actually holds it in better. So you really gotta fight to get these bars loose. Whereas this one, I guarantee it, every time you change the sandpaper, these things are gonna fall on the floor and they're gonna drive you insane. So let's see if we can get inside this thing. Get into the clamshell here. We've got 4 fasteners in the side. We theoretically removed, like buried halfway to China in here, which is actually good. Whenever you see a tool or something, anything that's injection molded, where the fasteners are sunk in like this, so that inside the mold, like when we look at the clamshell, they've actually like brought in a tube for it to sit in with a face on the inside. This is actually a good thing, because if they just put the screws on the outside, then you're clamping it over like 2-3 inches here, and you've got these long screws and they flex relative to each other. You want the mold to bring the screws close together so that you don't have to mess with that. Otherwise they'll flex, right? The longer the screw, kind of the worse it works, and the more expensive it is. So they're spending more money to make the thing, and the performance is worse. So good on the top. What the fuck is going on? Come on. Oh, there's one of them. Well, you know, I'm sure this wouldn't be so difficult if you were not as stupid as I am, and you could use a screwdriver. You know, it's a complicated tool. There's this part and this part. Yeah, give me some credit, man. All right, that's where we're gonna go to the quick cut for you. You know, one thing I'll say about this while I'm messing with these screws is that this switch on the front is surprisingly heavy on the snap action for a cheapo. Normally with these cheapos, it's like super flimsy, and I always like the heavy snaps, right? Well, it doesn't snap now, I've got that clamshell off apart. I always like it heavy, you know, the big snaps, so it stays where you want it to be. But the problem here is that there's no good way to get your hand around this. Like, the only surface you have to push on is like the tip of your finger, like that. Right there, like, what is that, like a fifth of my finger gets to push on the side? This stuff isn't really enough. It's heavy enough on the snap when it's actually put together that, there we go, here, I'll show you like this. So, you could do it like this, but if you're wearing gloves, and you know, your finger moves relative to the glove or something, like this is kind of a pain. So, if this was made better, it would like come out. It would have a little bit like of a hump or something, so you could just, you know, stick your finger on the side and actually use the switch. This switch is really inconvenient. I found that when I use this, I'm like taking my other hand. It's just stupid. It's wasting your time. So we got to take off the bottom plate too. You know, it's important that you don't make it too easy to take apart your shitty tool. If you're gonna make shitty tools, pro tip, make sure it's not easy to take it apart. Everyone's gonna see the dirty shortcuts you took inside. The housing is just ABS plastic, the clamshell. Well, everything so far I've seen is ABS plastic. There's no, like on a proper tool, well, we won't say proper here. On a tool that comes in one of the team colors, right, for one of the major players, they all use glass fiber reinforced nylon. So it's a nylon plastic, and then inside of it there's like basically like fiberglass strands, and it makes it a lot stronger and a lot less brittle, and it increases the strength in tension and all sorts of stuff. It makes it stronger, more better. More glass fiber, more better. But it's expensive because the glass fiber is like super abrasive. So when they mold it, it wears out the mold faster. There's stuff they do to mitigate that sometimes to make it cheaper. You know, making a mold, if you've ever like looked into it, it's really expensive. These mold makers, so they machine it and all this stuff, and it's like, man, I looked at a quote once for this like little tiny motor housing, and it was gonna be like $30,000 to do the mold making, and then they'd cast it. So it's not cheap. That wasn't with plastic, but with anything, the tooling is a huge part of the cost. So, and the tooling has a life cycle. So whether it's molds or even if it's an assembly line, and you know they have to set up some type of tooling, everything wears out, right? Everything craps out eventually. So there's a certain number of units per mold that they can do, you know, on average or whatever, and they have to bake that into the price. That's a huge part of the price, actually. Like, the plastic is super cheap. You're paying to pay off the machine that does the injection molding machines, and then you're paying for the damage that you're doing to the mold when they injected it. So a lot of what you pay for when you buy these molded plastic parts is is in metal. It's in the metal in some, you know, far-flung Chinese factory. Right? So you can see we've broken with the tradition of our forefathers, and we turned it on prior to taking it apart. Oh man, I see some shit I don't like. What? Okay. Alright, we'll get there. So yeah, this thing's had a hot supper. That's how I know it sucks so much. So just take my word for it. Again, someone's gonna be like, oh, if you get the Bosch 3000 super good Skookumon, it's not any good. It's no good. It's just a bad design. Do yourself a favor, spend like a little bit more and get one of the random orbit sanders. And they market them on the random orbit. The random orbit sanders, like, they do a variable path with the sanding surface, and the idea is that you get a better finish because you don't rub in like the same little I actually didn't find that to be a problem with this. When I sanded stuff with this, I didn't see like patterning, like little ovals all over it, little swirls or whatever, which can happen. It might just be the type of wood I used it on or whatever. So that wasn't a problem, but the random orbit ones, and I have my new one now, so we'll take that apart too, and we'll look at it. The random orbit ones attach with Velcro. So they have discs, circular discs, and they Velcro on. And the Velcro eliminates this problem where we have more travel in the actual moving part than we do in the sandpaper. So just for that reason alone, I'm not dealing with these springy bars and it coming off and it tearing, and it falls off like so many times when you're using this thing. Use it a little bit, sandpaper comes off. Oh, it sucks. And use it a little bit more, sandpaper comes off. And so you gotta put it back on. But then when you put it back on, oh, this thing falls off. And then, you're working on a deck or something, or you're on a job site, you drop this thing, man, it's gone. You drop this on a job site, you're fucked. Like, what if you're on the second story of some building, sanding something down? I mean, I guess no one's using a corded sander, and you know what I mean, man? Like, you don't want to drop little pieces of metal. I was working on a deck, dropped this right between the cracks in there. And luckily, this thing, like, it, caught like that, but it just made me think, like, man, these things will disappear on you, and then you're fucked, Alright. Set that aside. Man, I'm gonna make a mess. Alright. Let's set that aside. Oh, look at that. Is that a little, like, roller bearing? Oh, yeah. Alright. Neat little bearing in there. So you'll quickly learn I'm not a machinist or a mechanical engineer. So I don't know what the different types of bearings are called. But if you've seen the bearings that are like, they're flat, I think they're called thrust bearings. They're flat, they look like a washer. They've got little cylindrical rollers along the faces. Like, they're inside automatic transmissions, all sorts of places. This is like that, but facing in towards the shaft. So it does the purpose of I don't know if this is like just a bearing without an inside part, but the rolling elements, if you can see inside of there, probably can't use a goddamn camera. The rolling elements are just directly exposed. So there's no inside half. It's like the outside half of a bearing. I don't know why you would do that. Man, there's no oil in there either. Or grease or anything. So, I would guess this is gonna break. It's not gonna last very long, I'll tell you that. It's just exposed rolling elements. So, if you got some humidity, or I don't know, you sneeze on it, and those things rust to shit, it's dead. It's done. Alright, so the first thing, I already can tell you how this thing's gonna break when it breaks. But it won't break. And the reason is you'll throw it out and you'll smash it to pieces before you ever work it to death. But let's pretend someone manages to use this thing without going insane, right? We can already see how it's going to break. There's no epoxy or anything on the rotor windings. Obviously they're enamel coated, but barely. Alright, camera died. Well, we're back. So, while you were gone, you didn't miss much. I kind of ripped the cord out a bit. Speaking of the cord, I would show you, but the printing on the cord is actually like press printed. So it's like it's not printed in ink. It's like texture only. So it's almost impossible for me to read. So there's no way you're going to be able to read it on camera. It says 105 degrees C, which is a lot higher than I expected. And I think let's find the gauge again. It is a Zhenjuan Huan brand. CSA listed. Canadian Safety Association. 105C. What does that say? 18 American wire gauge. I don't know, man. This stuff's hard to read. Might have better luck than I do. So let's show you right here. So so here's the cool thing with this. So a couple things are shitty. Well, everything's shitty. There's no cool thing here. I don't know what I'm talking about. So the biggest problem that I see so far is, well, all the problems are big, and there's more than one of them. There's one cool thing in here. We'll show you that first. We'll start with the redemption, and that is cleverness. It's probably not even, good in terms of design or build, but it's clever. So the switch that we were talking about, how it's nice and sturdy. So the switch is this guy, right here. Boom, super sturdy. But behind the curtain, if we pull this out, what? Look at this. It's not like a normal tool switch. It's just a regular little. It's a regular little micro switch. Check that out. Just like your standard. It's even got the symbols on it. Like they're expecting a human to press this. The guys who made the switch. It's got the little circle and the line for open and closed respectively. Man, that's neat. And then the way that it's being actuated is this thing has like a little lobe on it. It's got these guys. And these guys slide back and forth, and they push on the switch right there. Sound effects make it understandable, and it switches it. So that's neat because they saved money, right? Like the tool switches that you'd find in most tools are more expensive than these. These are just super jelly bean. They're probably getting these for a cent or two, a couple cents, by the metric ton in China. So, which is also true for the tool switches, but these are definitely cheaper. So that's a neat little mechanism. It seats right in here. The mold is all designed exactly for the switch, and this actuates it. And you actually get a really strong snap action. So, I expected, because of this linear motion, that there'd be some type of, like linear side-to-side switch, not this rocker. But, this is actually, if this piece was made better, or shaped better, rather, if it had like a more of a rise on the front so that you could push it easier, this would be smart. This would actually be a good way to save money, unless this fails. The thing is, they're switching AC, right? This is a commutated AC motor, and AC is really easy to switch. It's not like DC. When you break current, let's say my hands here are the contacts, and the current's flowing and they're closed. As soon as you start to pull them apart, right, there's a moment in time when they're like, just a hair, just a curly one between the two of the contacts, and the voltage will break down the air, it'll ionize the gas, and it'll arc. And the arc is really easy to start when they're close, and it's easier to keep the arc going than to start it. So even as they travel, you'll still have an arc for a while, and these arcs are bad for the contacts. It's what kills the switch. It's arcing inside, eventually burns it out. So what makes AC easy to switch is that it's a sine wave, right? So a sine wave's going up and down, above and below zero on your x-axis. So 60 times per second, if it's 60 hertz power, like you get out of the wall, it crosses 0 volts. So this arc will start as you start to separate it. But as soon as the sine wave, within at maximum 1/60th of a second crosses 0, the arc dies because there's no voltage and there's no current to sustain it. So DC is difficult because that never happens. So with DC, you need bigger switches because you physically need to achieve a large enough gap to extinguish the arc. And so they're more expensive, and they wear. The wear is harder on them because they've got more arcing and sparking going on inside. So this probably does just fine, honestly. It's got these little stake-on connectors. Those will probably do just fine. The way they were fixed in the housing, like one of them is smushed down into the bottom, which is actually a good thing because it won't go anywhere. It's stuck inside the clamshell. It can't really back off. And this top one will be stuck inside the clamshell when the clamshell comes down on top of it. So that's a good thing as well. That actually helps us. There we go. So onto the motor here. Is a super simple motor. This is a commutated AC motor. If you're not familiar with commutated AC, you are familiar with commutated DC. They are the same. The frequency at which the power is switching relative to the frequency at which this is spinning. This might be spinning thousands of times per minute. And so it's gone quick. So like the time between one commutation bar to the next commutation bar relative to the 60 hertz, it doesn't even know the 60 hertz is there. It doesn't matter. There's a point where there's no voltage, as you're crossing zero, and then there's a point where there's more voltage, where you're at the peak of the sine wave, right? But basically, it doesn't matter. They have more loss. Like they're generally less efficient because there's this mechanism called hysteresis loss in the core, which is basically that you pipe the magnetic flux one way through the core, which is this laminated silicon steel here, and then it switches directions within a 60th of a second, and it tries to pipe the magnetic field the other way, and the material here that the field is going through doesn't like having the direction switched. And there's some energy loss associated with that. That is lost in the form of heat, as energy is typically lost, and so it heats up. Anyways, this is laminated in that it's steel, insulator, steel, insulator, steel, insulator back and forth, like little plates. That's to reduce eddy current formation in the core. So you get these little swirling side currents that you induce. That's also a loss mechanism. It causes heat. Anytime you have current flowing, you're producing some amount of heat. So making a bunch of thin laminations reduces the area in which these currents can flow. So it makes it more efficient. They actually frequently won't work if you don't do this. If this was a solid chunk of steel, this motor might not work at all. The eddy current losses can get so extreme that you just generate a ton of heat, and like half the energy you're putting in is going to heat, and the thing just melts itself to death and it doesn't spin. So why does this thing suck so much? I think there was a moment where I said that it looked alright. I don't know what the hell I was talking about. So as mentioned, there's just nothing. There's nothing holding these rotor winding leads on the commutator bars. They're just clipped right on there. They're gonna snap. So saying there's nothing holding them on is actually sort of a misstatement. They're fixed by these copper bits at the end. That's not the problem. The problem is that there's nothing to prevent this little wire run, right? Where you see the bicycle spoke thing going on here. There's nothing to prevent that wire from flexing. And as the tool spins and it vibrates, these wires will flex. Even if it's a tiny bit. Once it starts vibrating, everything vibrates. And if you've used a sander, obviously, it vibrates. So these will flex. Copper work hardens, so as it vibrates, it gets stiffer and stiffer until it snaps. And that's a really common failure mode with commutated motors. It's one of the most common failure modes. So most makers, if you buy the same tool, like the same quarter sheet sander, if you buy one of these from DeWalt or Milwaukee or Bosch or whatever, they're gonna have epoxy, it's like glue or silicon shmoo or whatever. Like it's gonna be all over here, all over the ends, and it's gonna hold it in place, and it's not gonna let it vibrate. And they might even dip some of this to prevent vibration as well. It's sort of a trade-off. It insulates it thermally, so it makes the thermal characteristics of the rotor worse, but it protects you against vibration damage. But the epoxy on this connection here to the commutator bars is essential. No even even bottom of the line tool from anywhere other than Harbor Freight will omit that generally, because man, they die pretty quick to that. If you drop it once, one of these might come off. Since the housing is ABS too, ABS is quite strong in some modes, but it's quite brittle. So if you drop it, the housing will crack. It'll spiderweb crack all over the place, and it'll be done. So these will fail. The housing will fail. As soon as you drop it once, it's going to shatter. What else is going to fail? These connections to the stator winding, the field winding here, are kind of sketchy. I can't quite tell what they are. It's like I thought they were stake-ons, but it looks like there's a piece of metal like jammed into these little miniature housings on the bobbin, and everything sort of shoved together inside of there. There's a little heat shrink, but that might fail. I don't know about that. This is gonna fail real quick. This will probably be the first thing to go. All right, the commutator bar connections. The other thing that's really sketchy in here is the brushes, man. The brushes. There's nothing good going on here. First of all, the brush housing is also, I was about to tell you that it was ABS, but I'd be lying to you. It says PA6 on the back. PA6, PA being nylon. PA6 is so it's not ABS. It might be glass fiber reinforced. I don't know if the PA6, let's see, let's try to cut it. See if it does that. See if I can cut my finger off here. Oh yeah, that's glass fiber reinforced. If you're not sure, just like take a knife to it, give it the old scrapey scrape, and if it's glass fiber reinforced, it'll make this chewing noise, like this kind of scrapey noise. As soon as you hear it, you'll know what I'm talking about. You're cutting the fibers of glass. So this is glass fiber reinforced. I would assume 15 or 30%. The mold mark only says PA6, so a more typical designation would be like PA6-GF30. They're telling you it's nylon, 30% glass fiber reinforced. That's actually what this, I don't know if we're in frame here. No, we're not. So that's what the bottom part is that holds the sandpaper. This thing. This has some marks on it. PA6-GF30. So this part is glass fiber reinforced. So it's not entirely ABS, but the housing is. That's, again, to save money on the mold. They want the mold to last. It's critical that these brush housings are glass fiber reinforced, because they get very hot. All the current that goes into the rotor, and I'll point out here, that goes into the field winding, because it's a series wound motor. So you see hot from the line comes into our switch, goes through our switch, comes into the field winding, stator winding, yeah, comes out the other side, goes into the brush. So they're in series. We can talk more about that later. If people are interested, I can make a video about different types of motors and maybe even generators. We can do a little electric machines thing. If there's interest, just let me know. You know where. So these have to be glass fiber reinforced. Glass fiber reinforcement is very good for the thermal characteristics. I mean, it's still a piece of plastic. It gets too hot, it's still going to turn to soup. But it is going to get hot, and this will turn to soup slower. And that also tells us why the housings are like these drop-in things. How they drop into the clamshell is because they're different materials, so they had to come from different molding processes. The problem with these, the spring, the preload spring, is super weak. It's super weak. So, and you can tell that, to be honest, just right away, because I don't know if my camera's going to be good enough for you. It looks better on camera than it does in real life, but the brush pattern is super questionable. This thing's been run for like at least 12 hours, and well, maybe 6 hours maybe in terms of true runtime, not like time I've had it around using it, but like on and like at task, loaded, and the wear pattern is like super spotty. There's some bars that are like barely worn, and there's like streaking, and it's not like groove streaking. Sometimes the brushes come serrated, and that helps them wear in like evenly. and seat properly. This is not that. This is like the spring is too weak to maintain good contact with the commutator bars. And potentially the commutator bar mechanism here, like that piece is not completely round as a whole unit. You know, some of the bars are like proud and some of them are hiding in there, and so it's not commutating well. The problem with that is, so there's going to be some power loss associated with the bad contact. That's not really a problem. The problem is that if the contacts are bad, and if you've got a loose spring that just gets looser and looser, right? As this is when the brush is new, it's pushed in there. But as the brush comes out, it gets worse and worse, looser and looser, because the spring is, you know, back here it's pushed in. Here you got barely any force. So, you know, to be clear, obviously the end of this brush stays in the same place, but like the inside backs out. So in terms of the amount of force, like out here is what it'll be like when the brush is shorter on the inside here. It can skip, and this has actually happened to me on one of my Ryobi drills. It like chipped or something, like the brush chipped, and it would skip when it hit this chip, this uneven surface. It would like bounce, the brush would bounce off the commutator bars, and just like those switches opening and closing, it would arc, and it would throw sparks. It would throw tons of sparks out the back of the drill. And I actually still have the drill, and we'll probably take it apart at some point, but it got better. So, you know, you just keep running it. You sit there, you hold the trigger down for a while until it's gone. So like you just wear the brush down until you wear through the problem. You do it until you wear it down until the chip's not there anymore. It's like buffing it out. You just waste brush until you fix it. But you don't want this weak brush that's popping all over and sparking, because it's a sander. So like I tried to clear this thing out, but it's full of sawdust. So if you're throwing sparks in there, it's gonna light on fire, and that's not good, man. Or, you know, you wouldn't have a sander, right, like in the oil patch or something, but let's say you did. Let's say you're the dumbass that brings a Harbor Freight $15 sander into the oil patch, and you just start throwing sparks all over. Yeah, good way to not come home, right? Good way to blow yourself up. So just in general, you don't want that. But particularly, the thing is full of flammable sawdust. And sawdust goes up quick, you know? It's like flour. I mean, nothing's quite as bad as flour. If you don't know about flour, look up some stuff about flour mills. If you've been to the Midwest, or you're from the Midwest of the States, there's a huge flour industry. And flour is super explosive. It's actually more explosive than gunpowder, but it can't be used in the same applications because it has to be mixed in with air. There's no oxidizer like in it, so it has to be like in the air, like fluffed up. But if it's in the air, if it's floating in the air and it ignites, it's more explosive than gunpowder per weight. And so there's these huge flour mills where they're running belt-driven equipment, electric drives on stuff, and so you get one spark in one of these. I would assume that they wouldn't use commutated motors because, you know, once the first guy blows up, second guy's wondering. And to be clear, I'm not talking about one guy blowing up. I'm talking about the whole flour mill. Like a 15-story tall flour mill blows up like a guy hit with like a tactical nuke. Like the thing goes sky high. Like in a flash detonation. It's not like it burns, like it explodes. It's a fuel air explosive. So the fuel is dispersed with the air. They exist in some military applications. Apparently they're highly effective in caves. You know, we won't go into that, but so it's super explosive. I'm not saying sawdust is going to do the same thing. I don't know about that, but I do know it's going to burn. So if you're throwing sparks in here, and you know, like look at this, man. Look at this. The back of this bearing housing right here, in between the bearing housing and the commutator bars. And when the camera died, I went outside and I blew all the sawdust out that I could. It's still packed with sawdust in there, right next to the commutator bar. So it's gonna light on fire. It's gonna start fire. This, you know, it's not a good idea. Yeah. The spring is super weak. I've actually never felt a preload this light on a brush spring, and it shows on this wear pattern. It's garbage. So, anyways, moving on. That's bad. That's no good. No good at all. So what else is no good? You know, we thought there'd be a cool mechanism in here. What, for doing the weeble wobbling orbits or whatever. It's not. It's this. So this stuff is polypropylene, so that, you know, these legs go in here, slot down in there, kind of, and the thing moves, and this gives it, you know, way to gyrate around. You know, more vibration. You know, happier your wife. So that's how that works. Okay, let's elucidate this a little bit more. This thing in here. Check our framing. All right. This thing. Oh, here, focus. Come on. This thing. The shaft is off center in the bottom here, like purposely off center. What that does is it makes this thing act like a cam in your car's engine. If you don't know what a cam is, it's where you take a shaft and you put the shaft into a thing shaped like an egg. And the shaft goes in the middle or wherever, and the thing's shaped like an egg. And so every time it spins a cycle, it's able to push on something. It's able to do a little push with its lobe, like the pointy bit of the egg. So this is like that. And then this part that we talked about, that's also glass fiber reinforced, it gyrates it around with cam action. So the part that, you know, if it's off center, the part on the opposite side of where the shaft is located to is poking out more, and so it's pushing this out more, and then as it goes around, you know, now that I've realized this, I think this is the purpose of this weird bearing, is that I think it's like a slop bearing. Not a technical term made up by me, but since the thing's off center, it's like rattling around in there, and it's moving this by the cam action of the aluminum casting on the outside. And so it's not actually, this just has to like not get chewed up. So it's got roller elements, and it won't actually be contacting all the rolling elements at one time. You know, it's off center, so there's play in there. I think this is some type of bearing designed to allow like sloppy play. So, you know, any side you touch, you can rattle around, but there's no interior grabby bit. You know, the fun part, it's missing. So what more to say? The brushes suck. We'll talk more about motor types later. If people are interested, let me know. This is a series wound commutated AC motor. We can talk about that. We can talk about how the cores work and what the purpose of the cores is. Well, the only thing I've seen in here that's any good is this fan, actually. You can take apart expensive drills like Milwaukee's and stuff, and the fan will be way smaller than this. So it's got a pretty big fan. And it's actually got some, you know, they curved it for you. You know, how nice of them. You know, it's got, you know, proper impeller business going on. So that's good, I guess. It's not going to die of overheating. I mean, it could. It could die of anything at any moment. But it's going to die because the wires are going to come off the commutator bars. That seems pretty obvious to me. Is that this is the failure mode. This is what's going to go wrong first. Any little bit of vibration for any extended period of time. I mean, it hasn't broken yet. I'm almost sort of shocked that it still works. I'm pretty shocked. The other thing that's worth pointing out is that they've put this thing for a vacuum, this dust connector. This thing's fake. I'm using that a little bit liberally. But I don't want to focus. But it's not going to work. Because this plate goes in front of this, right? This plate goes up here, you know, tilted up. But this plate goes here. And the sandpaper goes on this plate. So in the velcro ones, there's holes in this pad, which there are in this one as well. There's holes here, there's 4 of them. And the idea is that the airflow is in such a way that it creates negative pressure on these holes. And there's holes in the sandpaper on the velcro ones, on the random orbit sanders. There's holes in the sandpaper that you line up with these holes, and the fan in here creates negative pressure, and it sucks sawdust up towards the extraction hose. But on this one, there's no holes in the sandpaper. So it's like that, and these are the holes. So it's no good. It's no good. It's not gonna work right. It'll do something, I guess. Like something will get in there, but it is a stupid design. So, maybe if you hooked a vacuum hose up, you'd get some negative pressure, and you'd actually sand a little bit better. Who knows? Oh, man. All right. This one hurt. Hurt to look at the insides. This thing sucks. I think I said this already, but the point to be made here is that as much as this one sucks, if we took apart like a Milwaukee one, I was at the store, Milwaukee does make these quarter sheet sanders. Like the major companies make these too. I don't know why, but they want to sell something to the guy who's got, every dollar that you have to spend. Like if you've got $10, I've got $12. Next guy's got $15. Like they want to hit every bit of the market with coverage. So they want to sell something for the cheapest guy, the marginally less cheap guy, then the marginally less cheap guy than that. So I guess they're selling them, but they suck. So no matter who makes it, don't buy it. Don't buy a quarter sheet sander. The principle of how the sandpaper is affixed to the sander is bad. It just doesn't work. What else can we learn from this? This is polypropylene, this piece right here. Because if this was ABS, like the clamshell, it would break. ABS, we talked about, is brittle. It's also rigid. So the purpose of this is to flex. This is designed to flex. It's designed to be bendy and allow the thing to move side to side while still being somehow mechanically attached to the sander. And so they've got this. That's why it's polypropylene. Polypropylene is flexy. In a lot of applications, that's bad. Like polypropylene is one of the most common 3D printer filaments and the cheapest. I don't 3D print, so I don't have the numbers or anything, but a lot of 3D printed stuff is polypropylene, and it's generally not a very strong material. But in some applications where you want to have play and you want it to be able to flex and not be rigid and brittle, like ABS is much stronger in like the classical modes, like in compression and all that stuff, but it's brittle, it's brittle and it's rigid. So other than that, what can we say? This guy, the connection between this was connected to the other brush. It came off while the camera died. It's like not even a stake on. It's like a little metal paddle that they just kind of like shove in the back. I think it's retained by the back side of the spring. Like they have copper on the back of the plastic piece. They have a little copper like in there with a little play, and then the preload spring that pushes on the brush is in between this copper contact right here and the back of the brush. And so it's doing double duty, holding the wire in between these two contacts and pushing the brush onto the commutator bars. That sucks because as we talked about this spring, man, I wish video could let you feel the shitty chintziness of the spring. It's no good. So it's doing double duty, and it really looks like it would be no good at either of them. So, yeah, that's a weird one. In normal, you'll see, right? I'm gonna make more videos. We're gonna take apart some better tools, and you'll see how they attach to the, or if you're watching around on YouTube, you can see elsewhere how they attach the actual leads to these. And normally, the brush itself is attached to a little braided wire. All right, surprise cut got us again, boys. So we're back. Don't mind the surprise cut. So what I was saying is that there's a lot of better ways of attaching these brushes, right, to the rest of the deal, to the rest of the rig. The brush itself has a wire attached to it, a little braided wire that's built in. Yeah, and it's still in this one. It's like inside the housing. You can tell that these are not designed to be replaceable. So that's some of the weirdness going on here, is that you can't actually access, you can't get to the back of these. There's no way in there. So the little wire comes off the back of the brush, and it goes internally to one of these contacts, and then they just jam that thing down in there, best I can tell, between the two pieces of copper. Anyways, before we go, closing remarks. This is what a random orbit sander looks like. This is the kind you want. Not Ryobi specifically. I have no Ryobi doesn't owe me anything. So I just have Ryobi tools because they're cheap. I have a lot of them. I've got different stuff too, but they're sort of the cheapest of the tools in a Home Depot or something. They're made by Tektronix Industries from Hong Kong. Same guys that make Milwaukee. And made might be an exaggeration. They're technically like a holding company. So, you know, who knows exactly how much of these companies is independent, how much is the same. It's been said before about wiser men than me, but I can't imagine that they're hiring different people to do the same thing more than once. They also make Rigid, the Home Depot generic brand. So the Ryobi and the Rigid, which are kind of the same thing, are sort of just the cheapest tools you can buy that aren't from Harbor Freight. So I have a lot of them because I don't have a bunch of coin to drop on tools. But you know, you buy whatever suits your fancy. But just the type of machine. This is what a random orbit sander looks like if you're not familiar. You'll notice it has these holes we were talking about. It actually sucks air up through those holes. So there's no vacuum hose here. Without a vacuum hose, this little thing, you know, is a joke. But you can actually attach a vacuum hose, and it'll actually work, man. It'll get dust, you know, less in your lungs. Never a bad thing. So you know, that's neat. And so you can see that this, man, I guess I got no way to show you. The Velcro's good. You know, people hear Velcro and they think, man, that must suck. No, it's good. Just trust me. It works good. So yeah, take it easy. I'll see you next time. Oh, nope. I'm back. One more comment on the random orbit sander. If you're inspired to buy one of these and you go to the store, they sell lots of cordless ones, right? They want to sell you a cordless everything. Everything they want to be cordless now because they're getting into the battery business. I have a feeling that they're going the way of printers, like where like they're gonna make the money on the batteries and they're gonna sell the tools cheaper and cheaper, like at more of a loss, so that they can sell you more batteries. And that they realize that's where the money is. If they can get you using their tools, commit you to their ecosystem, as they'd say, you know, that's where they're gonna make the most money. Is selling you the batteries and the battery chargers, and then once you're in deep, you'll keep buying their tools. So you know, you got 30 Ryobi batteries. Are you gonna go buy a DeWalt that uses different batteries and you can't? No, you're not. It'd be stupid. You gotta buy more batteries. They're expensive. So anyways, well, you do whatever you want to do, but I wouldn't buy a battery-powered sander. And they're gonna hide these corded tools like in the back of the Home Depot. Like they don't want you to know they're there. So look for it. I wouldn't buy a battery-powered sander unless you also have a corded one, and you want the battery one for convenience, and you've got the coin to spend, because a sander, typically when you sand, right, you're sanding for a long time. Or at least me. Like if I make a table or something or whatever, you know, sanding's kind of a long process. So the batteries aren't gonna last. So I've looked at the battery one. Not only is it more expensive, not only do you have to buy batteries, but it says like 15 minutes of runtime, or like 13, like something pathetic. So, you know, for a drill, it's not a problem because you don't just hold a drill down continuously. You drill a hole and then you move on to the next one, and you know, it's a low duty cycle. But this is the kind of thing you turn on and you run it for an hour, you know, and then you get lunch and you run it for another hour. So it would just eat through every battery on the site or in your house or whatever, and you know, you'd be seeing it for 3 days, 10 minutes at a time. So, you know, if you want to get one to like get into that spot you can't reach, or you don't want to get the extension cord all the time, whatever. But if you don't have a corded one, you don't want to just have a cordless one, I think. You know, I think you'd kill batteries instantly. So that's a comment for what it's worth. You know, make sure you're thinking about that when you buy one. Get what's gonna fit you. Take it easy.